If you are just coming across my video, you are welcome, and make sure you like, follow and share. What do we mean by enols? Enols have two words. So we have two words in enol, that is ene plus o. So that give us enol. That's where we see enol. In the sense that it's going to have double bond. Do you get it? So it's going to give us double bond. And o from alcohol. So all is from alcohol. So now, how do we form enol, and how are you going to identify compounds that are enols? In enols, so enols always have double bond. It will have double bond and hydroxyl group at the same carbon. Usually the alpha carbon. So in enol, we usually have double bond. So it will have double bond. This place double bond and hydroxyl group at the same carbon, usually the alpha carbon. For example, let's say we have a compound like this, and we have OH here, we have CH3, and this place is also CH3, and this place is H. Now, this particular carbon, let's say this is carbon 1, carbon 2, and carbon 3, right? At carbon 1, we only have hydrogen that is attached to it. At carbon 2 here, we only have the double bond and the hydrogen at this point. Do you get it? So for carbon 3 now, if you check carbon 3, we have the alkene group and we also have the OH group. That means this particular carbon have in, because if you want to name this, you can say 1, 2, 3, 4. So we have 4 carbon. You can say butene, but because of this particular OH here, you cannot call it butene. So this particular carbon 3 have alkene group, it have alkene group and the OH group. So that makes it an enol. So this is an enol because you cannot call it butene because of the double bond. If you call it butene because of the double bond, you are wrong. But we have OH group there, and you cannot call it butanol. You cannot call it butane. Likewise, you cannot call it butanol. But instead, this particular compound there is an enol compound. So it is an enol because it have double bond and the OH group. Now, let's try and solve some example more. Formation of enol. We can form enol in different way, but most of the time we usually form it through resonance. So it is by resonance. So most of the time it is by resonance. What I mean by resonance is you converting one group to another. When you convert one particular group to another, or from enol back to another functional group, that is what we mean by resonance. And usually, number one, carbonyl compound is converted to enol. So let's say we have something like this. We have double bond here. This place is hydrogen. Now, if you want to convert this to an enol, so what you are going to do now is, at this particular carbon, we have one more hydrogen, right? And here we have CH3 at this point. So this is CH3 and this place is also CH3. I told you earlier that enol usually have double bond and hydroxyl group at the alpha carbon, right? At the alpha carbon. So this is our alpha carbon here. So one of the hydrogen at the alpha carbon, we have to donate its electron. So it's going to donate one of the electron to the carbon here. So once it donates the bond that is here, this particular bond at the oxygen, we also have to shift. So if this one is coming, if one bond is coming, another bond we have to shift. So this one coming here, shift one bond of the OH, there is going to give us something like this. So this one will become O minus, oxygen minus, and we have CH3 here. This one will have become double bonds, then we have just one hydrogen left, then this place is also CH3. Now the next thing you have to do is to react it in the presence of hydrogen. So H plus, the presence of H to give us something like this. So this one is CH3, and this one will have become OH, and this place double bond, and our CH3 will still remain here. So we are converting from carbonyl, we converted from carbonyl to enol. So this is our enol here, because we have double bond and OH group at the alpha carbon, or let me say the same carbon is having the alkane, which is the double bond, and the hydroxyl group. To the next example, now let's do for aldehyde. For aldehyde, let's say we have a compound like this. So we are using aldehyde, that means we are having something here. This place is double bond O, right? And we have H here. So this one converting to enol, this is an aldehyde, which is a carbonyl compound. So this is a carbonyl compound, same thing that we have done the other time. So we are repeating the same step. You know, oxygen always pull electron toward itself, that is inductive effect. So through inductive effect, one of the bond here we have to shift to this side. As I've said before, you coming here, one bond also have to leave. So one of the bond on oxygen 2 we shift back on oxygen, then we are going to have something like this. One of the bond have shifted here, so we have double bond. So it will have shifted, then this place will become O minus. Same thing that we did the other time, in the presence of H plus, that is hydrogen ion, then this oxygen here is going to pick this hydrogen. So once it picks it, it's going to give us something like this, which is our enol, right? So we have two bonds, then this place is double bond, then this will have become OH and our H here. So we have the hydroxyl group and the alkane group are the same carbon, that makes it an enol. So this is our enol. To the next example, but that one is going to be an exercise, homework assignment. Make sure you do it and drop it in the comment section. So now here is the assignment. Let's say you have a compound like this. You have double bond here. Let's say you have double bond here, right? And this is hydrogen here. Then you also have one hydrogen here. So this is a carbonyl compound. So give me the enol form of this compound. What's going to be the enol form of this compound? Drop it in the comment section. See you guys in my next video.